Today we will consider Euler's method for solving linear homogeneous differential equations of second order and beyond. General form of this equation is the following, where p1 and p2 are real numbers. To find solution of this equation, we need to find any linear independent solutions, any two linear independent solutions. According to Euler's method, we will find them in form y equals e power lambda x, where lambda is a complex constant. So if y equals e power lambda x, so y prime will be lambda e lambda x, y second prime will be lambda square e power lambda x, and substituting these three expressions in the initial equation, we will obtain e power lambda x lambda square plus p1 lambda plus p2 equals 0. E power lambda x is non-zero, so lambda square plus p1 lambda plus p2 will be 0. This polynomial is called a characteristic polynomial of this equation. Let this equation have two solutions, lambda 1 and lambda 2. They can be real but different. This will be the first case. First case will bring us two solutions. y1 of x will be e powered lambda 1x, y2 of x will be e power lambda 2x. And general solution of this equation, of the initial equation, will be c1 e power lambda 1x plus c2 e power lambda 2x, where c1 and c2 are some real constants. Next, situation where we have lambda 1 and lambda 2 are complex numbers. Then first solution will be e power lambda 1 x, second solution will be e power lambda 2x. Let lambda 1 be alpha plus I beta and lambda 2 be alpha minus I beta. These two complex numbers that differ only by this sign is called complex conjugated. So if you substitute these two numbers in our partial solutions, we will get, using the Euler's formula, alpha plus I beta x will be cosinus beta x plus I sinus beta x multiplied by exponent alpha x. This will be y1, y2 will be e power alpha minus I beta x will be cosinus beta x minus I sinus beta x e power alpha x. So, solution of the initial equation will be y equals e power alpha x c1 cosinus beta x plus c2 sinus beta x, where c1 and c2 are some real constants. Third case, when we have lambda 1 equals lambda 2 and lambda 1, lambda 2 are real numbers, then we can find one solution e power lambda x, as in previous cases. Second solution has to be linearly independent with the first solution. Let us consider it as e power lambda x by u of x, where u of x we have to find. Let us find this function. y2 prime will be lambda e power lambda x by u plus e power lambda x by u prime. Second derivative of y2 will be lambda square e power lambda x plus 2 lambda e power lambda x u prime plus e power lambda x u double prime. Then, if we substitute these formulas in our initial equation, we will get e power lambda x can be moved out of brackets, u double prime plus 2 lambda plus p1 u prime plus lambda square plus p1 lambda plus p2 u equals 0. Because lambda is the root of this equation as we initially stated, then this part will be 0 and this part will be 0. So e power lambda x by u double prime equals 0 will remain. Exponent cannot be 0, so we'll get u double prime equals 0. From here, u prime will be some constant and u will be constant c by x plus constant d. But here we can use any constants, so let us just put c equal 1, d equals 0, so u will be x. So linearly independent with first solution, y2 will be x e power lambda x. So we have two solutions, y1 equals e power lambda x and y2 equals x e power lambda x. So general solution of the initial equation will be c1 e power lambda x plus c2 x e power lambda x. Let us consider some examples. First one will be y double prime plus y prime minus 2y equals 0. Characteristic equation will be lambda square plus lambda minus 2. We just take order of derivative and transform it to the power of lambda. Y transforms to lambda, order of derivative transforms to the power of variable equals 0. Let us solve this equation. Discriminant will be 1 plus 2 by 4, so lambda will be minus 1 plus or minus 3 over 2. So we'll get 2, 1 and minus 2. Using the Eulers method, first part of solution will be e power x, 1 multiplied by x. Second part of the solution will be e power minus 2x. So general solution will be c1 e power x plus c2 e power minus 2x. Next example. If we have y double prime minus 6y prime plus 9y equals 0, then we write a characteristic equation, lambda square minus 6 lambda plus 9 equals 0. Here we will have lambda minus 3 square equals 0, so lambda 1 will be 3 and lambda 2 will be 3. So we have two real equal solutions. Then, using Euler's method, general solution will give us c1 e power 3x plus c2x e power 3x. Another example. Y double prime plus 2y prime plus 26y equals 0. Then lambda square plus 2 lambda plus 26 equals 0. Let us solve this equation. We will have 4 minus 4 by 26, which will be 100 minus 100. So square root of the d will be 10i. So lambda 1 will be minus 2 plus 10i over 2, which will be minus 1 plus 5i. Lambda 2 will be minus 2 minus 10i over 2 will be minus 1 minus 5i. So we have two complex conjugated solutions. So we take these parts, real parts, as powers of exponent and these numbers as multiplicators under sinus and cosinus. So we will have y1 will be e power minus x multiplied by cosinus 5x, and y2 will be e power minus x by sinus 5x. And general solution will be c1 e minus e power minus x cosinus 5x plus c2 e power minus x sinus 5x. But how can we solve Cauchy problem here? Let us consider an example. Y triple prime minus 6y double prime plus 11y prime minus 6y will be 0. Y of 0 will be y prime of 0 will be 0, and double prime at 0 will be 4. So first hand we use same method to solve this equation. Write down characteristic equation and solve it. If we try to substitute 1 here, we'll get 1 minus 6 plus 11 minus 6 will be 0, so lambda 1 will be 1. Next, we use Horner's scheme to divide this polynomial by lambda minus 1. We just write down this solution, then coefficients of this equation, 1 minus 6, 11 minus 6. Here we put 1, and we just multiply this number by this number plus this number. So 1 by y minus 6 will be minus 5, 1 by minus 5 plus 11 will be 6, and 1 by 6 minus 6 will be 0. So now we have new equation, lambda square minus 5 lambda plus 6 equals 0. Coefficients are taken from here. After that, we just solve it as the usual quadratic equation. 25 minus 4 by 6 will be 1, so lambda 2, 3 will be 5 plus or minus 1 divided by 2, and this will be either 3 or 2. So lambda 1 is 1, lambda 2 is 2, lambda 3 is 3, and general solution will be c1 e power x plus c2 e power 2x plus c3 e power 3x. But in initial conditions we have y primes. When we solved higher order differential equations using general methods, we at each step obtained some derivative of y. Here we got answer directly from the initial equation. So here we have to find these y primes and then substitute initial conditions to find these constants. So y equals c1 e power x plus c2 e power 2x plus c3 e power 3x. Y prime is c1 e power x plus 2c2 e power 2x plus 3c3 e power 3x. Y double prime will be c1 e power x plus 4c2 e power 2x plus 9c3 e power 3x. Now we can substitute y at 0. Every initial condition has x equals 0. E power x or e power 0 will be 1, so each exponent will turn to 1. So we will get system of equations. C1 plus C2 plus C3 will be 0. C1 plus 2, C2 plus 3, C3 will be 0. C1 plus 4, C2 plus 9, C3 will be 4. Now we have to solve this system of equations. Let us use Gauss method. We write down coefficients and answers. After that, we transform this matrix to upper triangle form. So we subtract first row from second row and from third row. We will get 1, 1, 1, 0, 0, 1, 2, 0, 0, 3, 8, 4. Now we subtract from this row, second row multiplied by 3. We will get 1, 1, 1, 0, 0, 1, 2, 0, 0, 0, 8 minus 6 will be 2, and here we will get 4. Now we subtract from second row to third row, we will get 1, 1, 1, 0, 0, 1, 0, minus 4, 0, 0, and here we can divide by 4, 1, 2. And final step, when we subtract from first row, second and third. So we get 1, 0, 0, minus 4, plus 2 will be minus 2, and we subtract this, we'll get 2. And second and third rows are the same. And now we have our answer here. So C1 will be 2, C2 will be minus 4, and C3 will be 2. So the answer of our problem will be 2e power x minus 4e power 2x plus 2e power 3x.